Hi everyone. Today we're going to be talking about the idea of converting from factored form to standard form. So go ahead and follow along with your notes, and if you have any questions, feel free to let me know. So equations of quadratic functions take many different forms. Another form, besides factored form, of quadratic functions is called standard form. So standard form looks like f of x equals ax squared plus bx plus c. So again, I'm saying that a, b, and c are all different numbers. Okay, so you can convert factored form to standard form using multiple methods. You could use algebra tiles like we just did in the activity, or you could use FOIL. What FOIL stands for is first, outer, inner, and last. You may have learned this in a different math class. And then there's the box method, which we're going to be learning more about, and a bunch of different ways. So these strategies are some of the ways that we'll talk about in this class, but you could be solving these in different ways for other classes. Okay, so let's get started. So for the first example, what we're going to do is first we're going to find the standard form of this equation. So it's going to start off with f of x equals, but then we want ax squared plus bx plus c. All right? So one of the ways that I'm going to show you is called the box method. So for the box method, you just create a box just like this. All right? And then you place the factors on either side of the box. So you put x minus 2 here, and then put x plus 4 here. And then what you do is you use it like a multiplication table. So to figure out this box, you multiply x times x. X times x gives you x squared. Now, to figure out this box, you're going to multiply negative 2 and this x. So that makes negative 2x. To figure out this box, you're going to multiply x by 4, and that's going to give you 4x. And then finally, to figure out this last box, you're going to multiply positive 4 by negative 2, and that's going to give you a negative 8. So now you've got x squared minus 2x, positive 4x, and a negative 8. Here, you stop, you realize that you might have some like terms. The like terms, remember, are same variable and the same power. So here I notice negative 2x and positive 4x are like terms. So that becomes x squared, negative 2x and a positive 4x makes positive 2x minus 8. And this is my standard form of my equation. So I'm going to place that up here. So f of x is equal to x squared plus 2x minus 8. Okay? Now and then just to get some extra practice, we're going to find the x-intercept, y-intercept, vertex, axis of symmetry, just like we've been doing. So remember, for the x-intercepts, you take each factor, x minus 2 and x plus 4, and you set them equal to 0. So you've got x minus 2 equals 0, and x plus 4 equals 0. Here you would add 2, and you end up with x equals 2. So that's one of your x-intercepts, 2 comma 0. And then here you would subtract 4, you end up with x is equal to negative 4. So that's your other x-intercept, negative 4 comma 0. I'm going to go ahead and plot those. Here's 2, 0. Here's negative 4, 0. And I need to find the midpoint. So to find the midpoint, I find how many spaces are in between. 1, 2, 3, 4, 5, 6. So 6 spaces in between. That means that I'm going to go 3 in from each side. So here's 1, 2, 3, and 1, 2, 3. So because the length was 6, half of that makes 3 on each side. And that's how I find my axis of symmetry. So that was x equals -1. Now that I have my axis of symmetry, I can substitute this in for my vertex, -1, to find the y value. So I'm going to take f of -1 is equal to -1 subtract 2, -1 add 4. Remember, all I did here is I replaced the x's with -1. So now I use order of operations. -1 minus 2 is -3. -1 plus 4 is +3, meaning that this gives me -9. F of -1 is equal to -9, meaning my vertex is -1, comma, -9. So I go to the left 1 space and down 9 spaces. So here's my vertex right here. Okay? And the last thing that I want to find out is my y-intercept. Remember, for the y-intercept, you plug in x equals 0. So you go f of 0 equals 0 minus 2, 0 plus 4. So that makes -2, and that makes a +4. And when you multiply those, you get f of 0 is equal to -8. So my y-intercept is 0, comma, -8, which I can plot right here. So now I've got this point, this point, this point, and this point. And I know that this parabola is going to open upwards, so it's going to look something like this. Okay? Let's move on to the next example. Okay, so for example 2, again, I want to find the factored form. So what I'm going to do is I want to use a box method. So what's interesting here is I actually only have one term, right, and then x plus 2. So what I'm going to do is I'm going to make a box like this. It's just going to be -2x because I only have one term, and then x plus 2. So again, I use the idea of a multiplication table. I multiply x and -2x. That gives me -2x to the second power. And then I multiply +2 and -2x to get this box. And that gives me -4x. And that's actually my simplified form. So y is equal to -2x squared minus 4x. All right. Now I'm going to move on, find my x-intercepts just like I've been working on. So for my x-intercepts, again, I take both of my factors and I set them equal to 0. -2x equals 0. If I divided -2, I find that x is equal to 0. X plus 2, set that equal to 0. I subtract 2. That makes x equals -2. So my two x-intercepts are 0, 0, and -2, 0. So let me go ahead and plot those. I've got 0, 0, and -2, 0. To find my y-intercept, remember I substitute x equals 0. So I'm going to write y equals -2, parentheses 0, parentheses 0 plus 2. As a reminder, this was an x. This was an x. I got that just from my original equation here. Use order of operations. -2 times 0 makes 0. 0 plus 2. So that's 0 times 2. 0 times anything we know is 0. So my y-intercept, which I actually already knew, is also 0, 0. To find my vertex, I need to find the halfway point. So I notice here I got 1, 2 spaces. So half of that is just going to be 1 space. So I found my axis of symmetry is equal to -1. And now I can substitute that into my vertex to find the y value. So do the same thing that I did with the y-intercept, but I'm going to substitute in -1. -2 multiplied by -1 gives me a +2. -1 plus 2 gives me a +1. So 2 multiplied by 1 gives me +2. So my vertex is going to be at -1, comma +2. I'll go ahead and plot that. So that's to the left 1 and then up 2 spaces. So this is my vertex right here. So now I've got this point, this point, and this point. And I can see that my parabola is going to be facing downwards like this. Okay, this would be a good time to pause to try example 3 on your own, or you can follow along with the video. So example 3, again, I want to find my standard form. So in this case, my function is called h of x. And notice here how I've got 2 outside and x minus 1 and x minus 3. So what you could do is just figure out what x minus 1 and x minus 3 are multiplied, and then multiply all that by 2. So that's what I'm going to go ahead and do. So if you were to use the box method, you can set it up like this: x minus 1, x minus 3. X times x gives me x squared. X times -1 gives me -1x. -3 multiplied by x gives me -3x. And -3 multiplied by -1 gives me a +3. So now I've got x squared minus 1x minus 3x plus 3. Notice how these are like terms. These are my like terms. So that makes x squared minus 4x plus 3. Now, don't forget, I still have this 2 outside. So with this 2 outside, I can now distribute it to every term here. So 2 times x squared, that gives me 2x squared. 2 times -4x, that gives me -8x. And 2 times 3 gives me +6. Okay? Alright, now let's do some practice on this. To find x-intercepts, you're going to take each factor, x minus 1 and x minus 3, and set them equal to 0. For both of these, you would add 1 here, that makes x equals 1. Here you would add 3, and that makes x equals 3. So now you've got 1 comma 0 and 3 comma 0. So that's right here and right here. To find the y-intercept, you're going to substitute in x equals 0. So h of 0 equals 2 multiplied by 0 minus 1 and 0 minus 3. Again, these were my x's that I replaced. So this is 2, 0 minus 1 gives me -1, 0 minus 3 gives me -3, and this is all multiplication. So this gives me -2 times -3, which is a +6. So my y-intercept. So again, you get the y-intercept right here at the end. When you multiply -2 by -3, you get a +6. So your y-intercept was 0, comma 6. Again, that would go off the graph here a little bit. So here's 3, here's 4, here's 5, here's +6. So your y-intercept is somewhere right here. Okay, for your vertex, you need to, and your axis of symmetry, you need to find the midpoint. So halfway between 1 and 3 is going to be 2. So that's our axis of symmetry right there. X equals 2. And I can use that to substitute in for the vertex. So again, I'm going to do the same thing here, except I'm plugging in a +2. Just for the sake of space, I'm going to erase this green work. So now I'm going to write h of 2 equals 2 multiplied by 2 minus 1 and 2 minus 3. Remember, these were my x's that I replaced. So 2 multiplied by 2 minus 1 makes 1. 2 minus 3 makes negative 1. 2 multiplied by positive 1 makes 2. Multiplied by negative 1 makes negative 2. So my vertex is going to be at 2 comma negative 2. So that's to the right 2 spaces and down 2 spaces. So here's my vertex right here. So now I've got this y-intercept, this x-intercept, this vertex, and this x-intercept right here. So now I can go down and back up and draw that shape of my parabola. Okay, and that's the video for today.